Work. You guys learning how things work yet? You look excited. Okay, he's learning. Is it Annalie? Yeah. Okay. I got a few of you by now. Getting there. All right. Any questions or concerns? On the homework, lecture, things you've been reading in the text? Is it making sense to you guys? I got one response. Give me something. Head nod. How's this working for you? Does it seem foreign yet? Or is... No, it's all right. Okay. I haven't seen any no's yet. Or you'd tell me, right? So I'm trying to make it where I'm approachable. That if you don't understand something, I'd hope you'd ask. That's why we're here. This is your class to learn. Granted, I learn something every semester because the teacher always learns more than the student generally. But in theory, you guys are learning more than I am. I haven't said this yet this semester. I love teaching, if you can't tell. And I'm here to teach you. And I can teach you till I'm blue in the face. However, I can't learn for you. I can try to help you and misunderstandings and reiterate things. But for you to actually learn it, that's on your side. So I'll keep trying, and you let me know if something else could help. But it just doesn't magically come by me telling and you hearing it or just reading it. You got to internalize it a little bit. Just trying to prepare you, because the first test, I know, is always the weirdest because you don't know what to expect. And actually, you guys should know more what to expect. Honestly, the test questions are exactly like everything you've been seeing thus far. I'd pull them from the same pool. That was redundant, but you know what I mean. The textbook, if you haven't realized, the answers to the odd questions in the back of each chapter are in the back of the book. So you have all their test your understanding questions throughout the chapter. You also have the end of the chapter questions, and he answers all the odd ones to help you, for practice and understanding. I do clicker questions. I ask you lots of things. The homework, the test is just like it. I just pick different ones. So it shouldn't surprise you. It'll just be questions you haven't seen yet, but same style and everything. While I'm on that vein, there's 30 questions on the exam, multiple choice. I rarely have anybody feel like they didn't have enough time to think about each one sufficiently. Most people generally leave early. So. And since I'm on it, might as well tell you this. How many have read this? No. How many have not read the syllabus yet? Well, get on it. Just one. That's good. Because in there, you should have learned, and from the first homework assignment, I drop your lowest homework grade. So if you just bomb one, or you're sick, or for some reason you blow one, it won't even affect you if you do all the others, because I'll drop your lowest one. I also drop your lowest exam. So, because it's stressful sometimes. People just can do great on homework, but there's anxiety in a test and you blow it. So I drop your lowest exam at the end as well. Also, I let you make it up. Retake it, I should say. I see it a win-win. So, by the way, the exam's next Monday, right? Monday? We'll review Friday. If you come to class Monday and take the exam, then you have the chance to retake it. It'll be like a homework assignment on WebAssign. It'll be the exact same exam. So if you felt like you didn't do well enough, you'll have 2 days, open book, to look up the answers, learn what it was. See, that's the win for me. You actually look at the exam after you take it. So maybe you'll learn this stuff. But also, say you got a 70% on exam day. Well, if you look up all the answers, you could easily get 100%. I know, sometimes people go, well, it's confusing. Well, you'll do well, or you should do well. I will average the grades. And so you can make up half of the points you missed on exam day, up to half of the points back by retaking it. Does that make sense? There is just one caveat. Two parts to it though. One, you don't have to retake the exam. But if you do, I'm averaging it. So as soon as you start taking the exam online, if you only answer 2 questions and quit, you're hosed. So decide whether you want to take it or not. Yeah. That's all. Any questions about the exam? Yeah.
How soon will we know our grades to know if we...
You won't.
Okay.
Yeah. You won't. They won't have them graded that fast. So that some people panic. Oh, what if I do worse? That is a possibility. And I think this is my 5th year teaching it. I think only 1 person, maybe 2, have ever done worse, barely. What I have to say to that is I'm sorry. But since it's open book, I'm shocked you do worse. So if you think you did really well exam day, obviously most of those people don't retake it. But that'll be your choice.
Will you allow us to write down the questions, the numbers of the questions that we got wrong? So in case that happens, not that we got wrong, but we think we got wrong, so in case that does happen, we can go back and...
Oh yeah, you can take notes and everything. By the way, I allow you to have a cheat sheet. 1. So you can, I'm not big on memorization of formulas, you know. If you can't tell, I want you to think for yourself. So just having the formula isn't enough to answer these questions generally anyway. So if that helps you, you can. And so you could jot it down on there when you go home. Because I don't need your cheat sheet. Any questions about homework?
Yeah, I found a very interesting thing about our homework. If one question was 4 points, and if there are 2 sub questions for that.
Yeah.
If I do 1 right and 1 wrong, so the first attempt is 2 points. But even I correct answer, next time I try, I got 1 point. So should I leave that? Or
I followed most of that. Sorry I didn't get it all. You're on a question that has 4 parts?
2 parts.
2 parts, okay. So like 4A and 4B. All right, and so this is worth a point and this is worth a point?
Probably.
Okay. Are they...
4 points total. So if I try 1 time...
4 points total. Which one is it, by the way? Because that sounds not like me. Which one is it? Do you remember? Do you know? Is it on the current assignment then? Homework 4? I don't see any question worth 4 points total. Well, anyway, the point is if it depends on whether it's how many opportunities you get. Remember, if there's 3, you should have 2 chances to get those points. But you get, if this had 3 as well, you get 2 more chances for that. It's like 2 separate questions. It's just they're related, so I put them in the same question.
First time I do the A is right, but the second is wrong.
So you got it right, and then you missed that one? Well, in theory, you should get the 1 point for that one. Did you get it right the second time?
I got this right the second time, but I thought I got...
So for that, you should be getting a half a point. 50% of what you could have. If it's wrong, email me and I can fix things. Yeah, or just email me anyway, I can look at it. Does that make sense though? You should, yeah. If you missed it again and got it here, you'd get half of that. So every time you submit a wrong response, it knocks off 50% of the possible for that one. Anything else? Okay. Let's, where do I want to begin? Let's do some review on chapter 4. So let's do clickers. Then I'll do some demos. So the projector's coming up so you can see your session ID for ResponseWare folk. The channel's still 41 for your clickers. While it's coming up, I had a thought that I don't think I've said in class, but it's on the syllabus. If you're using ResponseWare, they suggest you use Uconnect network rather than your data plan or UGuest. Statistically, they have found that it doesn't drop you off or cut you out as often. So if you're finding that it keeps messing up on you, use Uconnect network. It seems to be more reliable with ResponseWare. Suggestion. Oh yeah. All right, while you guys still logging in, there we go. This way we can review some things. All right, it's open for responses. So if you have a 2 kilogram melon, what's the force of gravity acting on it? Oh, yes. Your response? Did you try it again? Just enter that session ID? Maybe.
When you ask you mean weight? What's the weight?
Yes, I'll give that to you.
Okay.
The force of gravity on something will be its weight. Yes. Didn't like it first? Yeah. Gotta love glitches. Mm-hmm. So everybody's, well, you'd tell me. All right. What do we got? 37. Looks like most of you have responded.
What did you do for yours that wasn't
It's open. People, the responses keep coming. Did you just re-enter the number?
Mm-hmm. Okay, there we go.
Maybe it just takes a while in cyberspace to catch up to speed. Everybody good now? First one's always fun. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Meh. Okay, 61% think it's 20 newtons, and the rest of you think it's 2 kilograms. So the force of gravity acting on a 2 kilogram melon is. So, those that answered C, why do you think people answered A? What? They didn't know G, the acceleration due to gravity? Which is 10 meters per second, or technically 9.8, yes. What else? Those that answered C, why do you think a lot of people answered A? Maybe they thought it was on the moon?
Yeah.
That's true. I didn't specify, but I think you can default Earth. Yeah?
I guess the incorrect mass and weight.
That's what I'm getting. Getting mass and weight confused. Mass and force. The force of gravity is your weight. That's the force that the Earth pulls you down with. That's a force. 2 kilograms represents a mass. That's how much material there is, and thus a measure of your resistance to a change in motion or inertia. Your mass doesn't change, whether we're on the Earth or the moon, but your weight could, depending on the acceleration due to gravity. Yes, I was assuming the Earth. If there's ever a confusion like that on the test, just ask me, I'll tell you, and then I'll fix the question next time. So, your mass is 2 kilograms. Kilograms is a mass, not a force. It's a unit for mass. So you would need to multiply that by the acceleration due to gravity. Mass times acceleration is force. That's Newton's second law. So 2 kilograms times 10 meters per second squared would be 20. And newtons is the unit for force. That's a unit for weight. In America, we're used to pounds. That's another unit for force. You'd have to convert to give them. But pounds and newtons are the units for force. Does that help? Oh, that is the one I want. Okay. Polling is now open. This is basically, what's the relationship with Newton's second law? How is force dependent on acceleration and mass? I hear whispering. You can talk to your neighbor if you want. That's fine. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ooh, we're split. 50 and 41. So either directly or inversely. All right, so now I'm gonna re-ask you this one. Talk to your neighbor, because you're split. Go ahead, discuss it, and I'll reopen the polling here, and you can re-vote. For those of you that aren't talking, I'll just tell you, statistically it's been proven that for some reason students learn better from other students. You could say the exact same thing to him and it would click that I say. So yeah, go ahead and keep talking. The polling is open, so if you have come to a conclusion, go ahead and vote. I'm just asking it again. Because I haven't told. Yeah. If you got it right the first time, I still know that. Ten, 9, 8, 7, 6, 5. Get your new vote in. 4, 3, 2, 1. What? Yep. Yeah, I'm re-asking it, so vote again. If you still think the same thing, choose the same answer. There's one more of you that voted before. Last chance. Going once? Going twice? You missed it. Well, that didn't help. Well, usually that always helps. Oh well, it's worth a shot. The correct answer might be just confusion with terms. Well, let's see here. I guess it doesn't matter. So, Newton's second law is this. Another way to write it is that and the way it asked it, for a given force, so this must be a confusion between understanding what's being said here. So let's go over it. For a given force, so we're not going to change F. Acceleration and mass, or how are they related to each other? Okay, if we're not changing F, then we're changing one or the other. All right. If the mass increases, let's say we double the mass, but you still push it with the same force. So you know what I mean? Okay, you double the mass. What's that do to the acceleration? More succinctly, because I couldn't make that out. But I could tell lots of you said something. It decreases. And how much? If you double the mass, how much does the acceleration decrease? It gets cut in half to keep this the same. That's the idea, that for the same force, same push, influence, you double the mass, you double the resistance, you double the inertia, it won't accelerate as much. It'll be exactly half as much. So these are going in opposite directions, so they're inversely proportional to each other. When you increase one, the other does not increase. Let's look at this for clarity. Let's say we kept the acceleration the same. And let's pick one you're familiar with. The acceleration due to gravity. It's 10 meters per second, correct? That doesn't change for all practical purposes. So for a given acceleration, how are these two related? Directly proportional or inversely proportional? When one goes up, does the other go up, or does it go down? Maybe I should make that a test question. Well, are you thinking it through in your head? If you double the force on it, what would you have to do to the mass to keep it accelerating at the same rate? You double it, so they both go up. So they're directly proportional. When one increases, so does the other, by the same amount. This is a good time to emphasize something I didn't do as much. Remember when we dropped the ball and the feather in a vacuum? And they both hit the ground at the same time? Why was that? No air resistance. So if you can get rid of air resistance, all things fall at what? The same rate. Okay, so who felt more force? The Earth's pulling on both of them down. Who felt more force? That was your gut reaction. Now think about it. They both have mass, correct? Do they have the same mass? So look back at there. If you have a different mass, but same acceleration. And I saw a light bulb go off there. So this is 10 meters per second squared for all objects, ignoring air resistance. That's what the Earth does. It accelerates them all at the same rate. But that doesn't mean it actually pulls on them with the same force. Which one does it have to pull on more? What's that? The heavier one. Because if you have more mass, like the ball, it has to pull on it more strongly, with more force, to get it to accelerate at 10 meters per second squared. So yeah, the ball felt more force. Now, let's relate this to your common sense. Which one's heavier? The ball. Its weight is more. Its weight is more. Yeah, it's heavier. Earth is pulling on it more. Heavier things feel more force because they're heavier. They got more mass. But they all fall at the same rate. Their acceleration's the same, not the force. That can be a sense of confusion. But it has to do with this directly proportional relationship between these two. Back here, these two are inversely proportional. The heavier ball would get accelerated less if they were pulled on the same amount. But in free fall, things aren't. It's the other way around. Questions? Yeah.
So what would that be about their speed then? Do they fall at the same speed or different speed?
Did they hit the ground at the same time?
Without
Yeah, they did. So that meant their speed would be the same. Because this is the change of motion, right? Change in acceleration. So they're changing the same because they have the same acceleration. So they both go from 0 to the same final velocity, same change, without air resistance. Good question. Anything else? Okie doke. Let's review some more. 26. Polling is now open. Oh, well, hey, look at that. Hopefully this will be easier for you. So had I not brought it up, this question would have. So if it helps, look back at this equation. So you're doubling the force, but you're also doubling the mass. How does that affect the acceleration? Ten, 9. Oh, question. So I'm just curious, are you on Uconnect?
Yeah, I think so. I have Wi-Fi right now.
No, well,
Crashing and I have to log back in.
well, for that matter, then try something other than Uconnect, and I can let TLT make a note. You hear that up there? I don't know. I don't know what's going on with the network. Do you have a data plan? Does it cost you? I mean, you could try. If it keeps kicking you out, it's not supposed to. Historically, Uconnect has been more consistent, but if it's messing up, try something else. You want to try now and answer? Oh, okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, 87% of you think it's the same. Oh, very good, very good. If this doubles and that doubles, it's like putting a 2 here. 2, 2. It's twice the force, twice the mass. So it's the same proportion, same quotient, same ratio, same acceleration. All right. Friendly reminder that in physics, when they say free fall, no air resistance. No air resistance. So what happens to the speed every second while something free falls? Now you got 3 things to worry about. Some people get confused. You got position, distance it covers. You got speed, how fast it's going to be moving, and acceleration, the rate it's changing its motion. This one wants the speed. Yes? Without. No air resistance. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Majority of you say A. Next, B. The answer is A. Increases by the same amount. Let's see, others were changes by increasing amounts each second. What changes by increasing amounts each second? Something does. What? Position, the distance. So The acceleration's constant, 10 meters per second every second. 10 meters per second every second. So it's constant. That means it changes the same amount every second. From 0 meters per second to 10 to 20 to 30 to 40. Every second it gains 10 meters per second, hence A. Increases by the same amount. But every second it is now going faster at the end of that second, correct? And things that are going faster cover more distance in the same amount of time. So each second it covers more and more distance each second. So the position would be changing with B. Changes by increasing amounts each second. Questions? What about if we threw the ball up instead of dropping it? Would that change your answer? Feedback. What's the acceleration on the way up? If you launch something up, it's still gravity. The only force on it in free fall is the acceleration due to gravity from the Earth pulling on it, which is still 10 meters per second every second. That means it changes 10 meters per second every second. So on the way up, it decreases by the same amount every second until it stops, turns around, and starts speeding back up the other way. Make sense? I got one more I'd like to ask you on here. Okay. Now we do have air resistance. So two objects, same size, but one's really heavy and one's not. Who's going to feel more air drag, air resistance? That upward force of the air pushing back against it. Yeah? Lead's really heavy, yes. So the lead one will be the drastically heavier one. Yes? Glad I can help. Oh, yeah?
Oh, no.
Oh, that you're still just...
So you're asking which one's going to go slower or which one experiences more force of air?
The second thing you said, the amount of air drag, which is the upward force that air resistance pushes on it as it falls. If it's falling far enough, has time to fall, yes, it can reach terminal velocity given enough time to fall, yes. That's not what it's asking, though. It might be the same answer, which one gets to terminal velocity first, but it's asking about that force. 10, 9, 8, 7, 6, 5, 4, 3, 2. Anybody else want to respond that hasn't the rest of the class? Yes, we got a 46. Woo! Sweet. So see, now we all know that we're all in the same boat and we need some more explanation. This one I feel like I'm going to go ahead and give you the answer. The lead one. But let's think it through more. That's the last one. So let's turn the lights back on. So I'm saying the lead ball experiences more air drag. So lead filled, heavy one, and lighter one. And they're falling. All right. So they both go, they both go. What do you think? Who will reach terminal velocity first? The lighter one? Why? Because this one will need more force because it's heavier, it has more mass. What's the state for either one? Let's draw a force by diagram at terminal velocity. In other words, let's understand the forces. There's two. Humor me. Gravity, so that's its weight. Its mass times the acceleration due to gravity. And the upward force is air. How do I draw it? Are they going to be equal? Was one bigger than the other? Good. Equal. So air drag, air resistance. If they're equal, the net force is 0. There's no net acceleration. Yes, gravity is still trying to accelerate it down, but the air is trying to accelerate it up. Right? This has an m acceleration due to the air upwards. And in this case, they're balancing each other. No acceleration, thus the terminal velocity. The velocity is not changing. It's not 0 either. It's something. So yeah, the heavier one will be bigger. Since its weight is more, it'll need more air drag before it reaches terminal velocity. Thus, you're right. This one will reach terminal velocity quicker. This one will keep falling and picking up speed, more speed, more speed, until that's enough to slow it down. So yeah, this one will experience more air drag. And he'll hit the ground first, because his terminal velocity will be faster than hers. Questions? Yeah?
Just a little off topic, but how long does it usually take for an object to reach terminal velocity? Or how far does it have to travel?
Totally depends on the object. Well, the feather and a piece of paper and a coffee filter you can see happen within, this far. A person, I don't remember, a lot further. Things that affect this, we're not getting into, that force, and things such as, well, the thing's weight, you understand that one, but also the density of the fluid it's going through, which is affected by pressure, height, elevation, temperature, viscosity, cross-sectional area. We mentioned that if you're like this, you'll fall. Your terminal velocity would be a little slower than if you're like that, because less air is hitting you, and all those would come into play. But they're all on the web too. We can look these up. We could calculate it too, but I haven't given you the formula for that. But I do know whatever the terminal velocity is for a human, it's too fast to survive. But for lots of insects and rodents, they jump from huge distances and they don't die. So this force is sufficient to cushion them when they land, or they don't weigh enough or too much to overcome that. Let's do another force by diagram one then. This is that air cart. It's a different one we did before. And it's going to blow air that way. So I turn it on. I can feel it. So the fan is exerting a force on the air that way. What's Newton's third law tell us? See, if the cart, fan, and so there's a force this way. Cart on air. It pushes the air this way. So what will be the reaction force? All forces come in pairs. I'm hearing whispering, but nothing auto that I can make out. Okay, there's a force this way. What on what? What's pushing what? You're right. Here's your clue. This one is the force the cart exerts on the air to blow it that way. So this one will be, there you go, it's the air on the cart. That's the force that can make the cart move, because it's on the cart. That'll affect how the cart moves. Let's do it. Ta-da! Whee! So, cart on air, reaction, Newton's third law, all forces come in pairs. The air pushes on the cart, and that's what propels it. That's like some of my favorite toys. This one. You guys blown up balloons, and when you accidentally let go of it, it goes all over the place? Well, this does that with a twist. So if the balloon pushes the air out the hole, what's the air do? Pushes back with the same force, same magnitude, just in opposite direction. That's Newton's third law. For every action, there's an equal and opposite reaction. Who has more mass, the balloon or the air? What do you think? The balloon. Think of it as a rocket then. Rocket or the fuel, the gas exhaust it shoots out. Yeah, the body, the balloon, the rocket is more massive. So for the same force, right, it's going to exert a force on the air and change its motion. But the air exerts the same force on the rocket and changes its motion. Same force. But we got two masses. We got the rocket and we got the air. So how will their accelerations differ? To keep it's the same force. So to balance that equation, here's that inversely proportional thing. If the mass goes up, what's the acceleration do? Decreases. Where this one will have a bigger one. To keep that product the same. So again, for the same force between the two, the one with the less mass, the air, or the exhaust gases, will accelerate more. So they're going to shoot out of the rocket faster than the rocket's going to recoil away. And that's what propels a rocket. My daughter loves that. Well, she used to, teenager now. But we can upscale this. Here's my rocket. I'm going to put some fuel in. This is methanol. Don't try this at home, kids. Let's squirt some in here. Yeah, a little more. All right. Now, a little lesson. Liquid alcohol isn't flammable. A lot of people think it is, they're worried. But the gas, when it evaporates, the vapor is flammable. So I'm coating the inside of this so it can evaporate and fill the inside of the bottle up. So we're going to get a lot of alcohol vapor inside. This is my rocket full of fuel. If we ignite the fuel, then it should increase the temperature and pressure, and it'll blow the exhaust gases out the back. And what do the gases do to the rocket? With the exact same force. Well, cross your fingers. Oh, that was nice. Maybe a little too fast. Okay, we're still intact. So lest you try that at home, that's a metal cap with a small hole in it. Plastic doesn't last so long. So a lot of people think rockets, or air rockets, water rockets, they need to be against the ground or a platform to push against to propel themselves. Bogus. Because rockets work in space, right? There's nothing to push on there. They push on the exhaust gases. They throw them out. The reaction is they push back. And that's what gives a rocket thrust. It's Newton's third law. They just react differently because of their masses. Since the mass of the gases isn't that much, they need to do it really fast in order to move that thing. All right, so quiz time here without your clickers. I'm going to put this on here and do it again. What will happen? Before, this pushed the air pushed the cart, and the cart moved. Now the air is going to hit the fan, which is attached to the cart through a magnet. What do you think? There's more forces going on now. What else do we got? Let's see. We'll add, for simplicity, I guess. Fan, and sail. Okay. What will happen now? Tell me something. Okay, something's pushing this way? What on what?
So the air's going to push on the sail, I guess.
Good. Okay, so there's a force this way. And that's the air on the sail. And the sail's attached to the cart. So that's a force on the cart. That'll affect the cart's motion. What's the reaction to that? If the air pushes on the sail, then the sail pushes back on the air. It'll stop it. It'll hit it and bounce off. That bounces that force. So we got 4 forces going on here. Which ones are on the cart? This one and this one. Do you think it'll move? Connection is the cart throws the air out, equal and opposite force back on the cart. Well, it's that air that hits the sail. It imparts the same force. So, I know I didn't draw it perfectly to scale. These should all be the same magnitude. Let's see what happens. Nothing. But if I were to just blow on it, if you push on the sail, it will move. But when the cart is doing the blowing itself, you got this whole thing going on, and the two on the cart balance. So there's no net force on the cart. That make sense? Hopefully this will help you do your last homework problem too, because that confuses people. My clue is, suggestion, look at the forces on the object in question. There's lots of other forces going on. There's always an action and reaction pair. They come in pairs. But they're always on opposite objects. This one's on the sail, this one's on the air. One more. It's quick. If you have a velocity of a cart going this way, but you have the medium moving like a train, or you're walking on an airplane, or a boat in a river, and that medium is moving this way, you can be going with the flow of the river or against the flow of the river. You can get different values for your velocity relative to the table, right? We've sort of mentioned this before. So if this is going 5 meters per second, and the river is going 5, you see it going 10 relative to the table? Or if I go the other way, this is going 5 that way, but the river is going 5 that way. You see how it stays put relative to the table? So you add and subtract these vectors. And my point is, you can go sideways. If this is 5 that way, and this is 5 sideways, I bet you can guess, your gut knows which way the car is going to go. This point, the car's heading out that way, but the river's moving that way. Which way will it head? It's got something moving it that way, it's got something moving it that way, it's going to end up going that way. Yeah, some result of components. And it ends up over here. So yeah, it made a diagonal relative to the table. We'll talk about those components more next time. See you later. Come with your homework questions. Look over what's confusing, what doesn't make sense, because next time's review, and the more questions I can answer of you, the